Okay, good morning. So, in the last lecture, we have started the unit number 3, properties on the fresh concrete, and we have seen the properties of the fresh concrete on the workability of concrete, then segregation and bleeding. So we have covered, and the effect on the workability of the concrete. Of the properties of fresh concrete, that also we have seen. So other some of the tests on the fresh concrete that we will see. So initially we have seen the workability, then we have seen the segregation, then we have seen the bleeding, and after that we have seen the how to measure the workability. It means by using the slum cone test. So various types of slum we have seen, and the slum may be steep slum, medium slum, low slum, and the range for the slum that we have seen that under the how to measure the workability of the concrete. So then some other tests we have to perform on that on the fresh concrete, that are the uh, uh, setting time of the cement, then air content on the concrete, and the unit weight and yield of the concrete that we have to see. So these are the three more methods or more tests we can perform on the fresh concrete also. So we will see one by one. So the setting time. So as we have seen in the unit number 1, setting time of the cement. So the very important the properties of the cement is the setting time. So there are two setting times are there: initial setting time and final setting time. So the initial setting time having not less than 30 minutes, and final setting time value is not more than 600 minutes for the ordinary Portland cement. So this what setting time that we have to see for our that properties of the fresh concrete we have to see. So generally we have to determine the time elapsed between the addition of the water when the paste is with the fluid and plastic. So if we add the water into the cement, so that water we are adding into the cements at the time of start time of the adding the water into the cement, and whatever paste we are preparing, and that paste we are filling into the wicket apparatus, and we are performing the test. So that period is nothing but the time elapsed addition of the water when the paste is in the fluid and the plastic stage. So that plastic stage, and that we are measuring the initial and final setting time. So for that purpose, we have as per the IS, the requirements are there. The initial setting time should not be less than 30 minutes, and the final setting time should not be greater than 600 minutes. So this is the setting time for cement. So why setting time is required? We have to calculate, or we know for the to know the properties of fresh concrete, because the setting of the cement is very important, where and that affects on the your properties of the fresh concrete. So the setting is there. Then the determining the time required for the paste to achieve the certain degree of hardness, as I told. So when that paste will hard, कोणत्या टायमिंग पर्यंत ती पेस्ट हार्ड होते, that is the we have to that time we have to measure. So initially setting should not be less than 30 minutes, as I told, and the final setting should not be greater than 600. So that time we have to measure. So if you see the graph, the rigidity on the y-axis, the rigidity given, and on the x-axis the time is given. So that the graph is showing here initial setting and here final setting. So that initial and final setting is for the as per the IS, as I told you, and that rigid concrete, when the rigidity of concrete will be, it means no workable, and plastic limit is what we can say, stop, it means rigid pavement or rigid paste will be formed. Up to that rigid paste form, we will note the time, that is the final setting time. So this is the graph shown in IS code also of for making the or some properties of the cement. IS code is given in the IS code, that the setting time properties also given. So this is the, if you see this picture, the picture shows the wicket apparatus, and here we are performing the test for the setting time of the cement. So this is the setting time. So if you see for the initial setting and final setting here, so blue indicate the initial setting, and the other color indicate the final setting. So this time or minute we have to measure while performing this test on the wicket apparatus. So if you see the here type 1, type 2, type 3, 4, 5 types are given, and here the setting time initial and final is also given. So the next properties of the fresh concrete or next test we have to perform, that is the air content. So the how much percentage of air is present on the concrete, so that we have to measure, and that air is required, that air content is also required while calculation of the mix design. So the very important that air content we have to calculate. So in the IS code they have given here, so the recommended total target air content for the concrete. So total air content for the concrete is here also given. So the air content in percentage we are measuring, and that percentage is we have to calculate by using this or by performing this. There are three methods for calculation of air content, that is the volumetric method, then pressure method. One more method is there as per the ASTM, American Society of the testing of material. So the first method is the volumetric material. So here volumetric cylinder is there, and we are measuring by filling the concrete into that. That is the air content by volumetric method. Second is the pressure method. So here the pressure, if you see in the second image, the pressure gauge is given. The concrete is filled or placed in that particular mold by the pressure, and we are increasing the pressure. So by pressure, how much air content is there, that we are finding into by the pressure method. So here, if you see here, this is the gravimetric method is there. So the gravimetric method is as per the American Society of Testing Material. So, this method we are using for the calculation of the air content also. So here they have given the procedure for calculation of air content by this gravimetric method. So here initially they have calculated the area of this bucket, whatever they have filled the concrete into that bucket. So T is the theoretical unit weight and W is the actual unit weight. So the theoretical unit weight we are calculating by the volume of this particular bucket into the density of concrete. So we will get the unit weight, but actual unit weight, so we will measure by this weighing balance, and we will calculate the actual unit weight by this gravimetric method. So the early age volume change. So early age volume change, it means the setting time is a very important factor, as I told, for the initial and final also. So early age volume change. So sometimes due to the air pressure, inside the air pressure, the volume will be changed in the early age. It means today we filled or cast the any slab, and tomorrow we have observed the cracks on the concrete. So it means the volume of that concrete will change. So why the reason of that volume of change of that concrete, if you see here. So pre-hardening shrinkage, the presenting the shrinkage, plastic shrinkage cracks. So the shrinkage phenomena is observed here. Shrinkage of concrete is nothing but the change in volume of the concrete. So the less than 12 hours age, it will be observed. So the cracks developed due to reduction of the volume in the fresh state is nothing but the your early age volume change. So also this happened due to the plastic shrinkage. Cracks are typically run parallelly into 1 to 3 feet and apart, and 1 to 2 inch deep can also in the irregular. So if you see in this particular image, so 2 to 3 feet length, the crack you can notice on the early age of the concrete. It means within 12 hours, within the 12 hours of casting, you can notice this particular cracks due to the change in volume. That is nothing but the plastic shrinkage cracks. And that concrete is due to the one vulnerable to the form of the attack. So due to the change in volume due to the plastic shrinkage conditions is happen, and that conditions happen, the change in volume, and such cracks will be noticed on the surface of the concrete. So what is plastic shrinkage? So if you see here, the plastic shrinkage. So the plastic shrinkage happens because the loss of water at the surface occurs. Loss of waters at the surface occurs the faster than the bleed water becomes the available. So this phenomena takes place, and due to that the plastic shrinkage will happen. So the absorption of water by the subgrade or aggregate. Sometimes what happen, as we have discussed in the last lecture, the whatever water present into the concrete, that water is absorbed by the aggregates. Whatever water present into the concrete or in the subgrade, that water is absorbed by the aggregate, and due to the absorption of that water by the aggregate, the for the hydration purpose, the water is a loss. So loss of water for the hydration purpose due to the absorption of that water by the aggregate. So due to that, the plastic shrinkage are happen. So why sometimes you have seen the cracks on the surface after the concreting. So that is the condition. So in the summer season, that phenomena takes place, or that phenomena happens rare time in the summer season. Why? Because in the summer season the aggregates are heated due to the much more heat, and if we add that aggregate into the concrete, so the water, whatever water we have added, the water may be absorbed by that aggregate, and so that the in the early age the cracks will be noticed. That phenomena is the plastic shrinkage. Are you getting? So the rapid water loss of evaporation, as I told in the last lecture also, the loss of water in evaporation also. In the summer season, there may be loss of water. So again, the concrete is too steep to flow, but does not have enough strength to exceed tensile strength generated by the shrinkage. So by the shrinkage phenomena, the tensile strength is generated, and that not enough for the or enough strength to exceed the tensile stress generated by the shrinkage. So that is nothing but the plastic shrinkage. So the tensile strength. So next strength we can conduct on the fresh concrete, that is the tensile strength. So generally tensile strength we are conducting by the split tensile test on the concrete. So here the time is given, any stress is given, tensile stress is given. So we generally we know the concrete is a weak in tension. Are you getting? So concrete is weak in tension, but strong in compression. So the tensile strength is also we have to measure, because because this shrinkage phenomena is observed in the concrete due to absorption of the water by the aggregates. So this tensile strength also we have to perform on the concrete. So this is shown in the graphically. Then the plastic shrinkage cracking, as we discuss about the plastic shrinkage, but the plastic shrinkage cracking, how and why happen? So this plastic shrinkage cracking happen, or to avoid the plastic shrinkage happen. To avoid the plastic shrinkage cracking, what we have to do? So we have to for avoiding this, we have to moisture subgrade and form. So whatever moistures are present on the subgrade or on the aggregate, that we have to remove. Then avoid absorption aggregate. So the aggregate which are absorbing the water, that aggregates we have to avoid for the use of the in through the concrete. Then erect a temporary with wind breaks and sunshades. Then cool aggregate and mix water. Why cool? Why we have to cool the aggregate? Because, so as I told, so water aggregates are absorbing water which is present into the concrete. Whatever water we are adding into the cement concrete, so that water absorbed by the aggregates. म्हणजे ते जे water aggregate जे आहे, ते aggregate काय करतात, water absorb करतात, की जे water आपल्याला heat of hydration process साठी required आहे setting time साठी, ते जर aggregate जर water जर aggregate ने absorb केलं तर काय होईल, तर shrinkage phenomena, plastic shrinkage phenomena will happen. Due to that, cracks will be noticed. So again, this plastic shrinkage phenomena is observed placing before the or placing, but before finishing. And also we have to adjust the mix design to avoid this plastic shrinkage cracking. Plastic shrinkage cracking आपल्याला avoid करायचं असेल तर आपल्याला mix design मध्ये adjustment करायला हवी. How? So retarder can reduce the early tensile strength. So retarder we can use, retarder admixture we can use for the early tensile strength. So to get the tensile strength for the concrete, so we have to add the retarder. So in this way, also some fiber we have to use into the concrete. So the fiber may be polypropylene, then nylon, then cellulose at the rate of 1 to 1.5 lb per cubic yard, then 50 to 70 million fiber per lb to increase the early tensile strength and crack resistance. So to resist crack or to avoid the crack, so such precautions we have to take for the plastic shrinkage to avoid the plastic shrinkage cracking. Okay, so these are the other tests on the concrete. Okay, so now next part we have to see that is related to fresh concrete is a placing of concrete and compaction of concrete. So till now we have seen the related to fresh concrete, that is the workability, then bleeding of the fresh concrete, then segregation of the fresh concrete, then some other test we have to perform on the concrete for the that required for the mix design. And next part related to fresh concrete is a placing of concrete. So the placing of concrete is also you have learned in the detail in the concrete technology, but so placing of concrete is a very important. As we have discussed in last lecture also, if we place the concrete from the height, जर आपण एखाद्या column मध्ये जर height वरून concrete ओतलं तर what will happen? So the segregation will be takes place. So the aggregates will be one side, cement slurry will be one side. So that phenomena will takes place. So placing of concrete is also very important. So how we have to place the concrete, so that we will see. So, and what is this process of the placing, that we will see. So see, it is a process of depositing a fresh concrete on its final position. So the final position, so it means where we are casting RCC column, we are casting the RCC beam, RCC slab, or other RCC components. So in that particular components, we have to deposit that concrete in their final location. So this is the process of depositing concrete at their location. That is the placing. So the before the placing of concrete, so formwork must be checked for the rigidity and cleanliness. So you have binded the steel into the column, but for that steel we have done the formwork or scaffolding. So whether that scaffolding or formwork we have done, that is the clean scaffolding, or that scaffolding is clean or rigid scaffolding, so that we have to check, and that is the must to check. Then concrete should not be dropped from height, as I told. It causes the segregation. So segregation avoid करण्यासाठी आपल्याला उंचीवरून concrete ओतणं avoid करायचं. The concrete should not be dropped from height as it causes the segregation. Then the wheelbarrow or vibrating needle should not be allowed to run over the placed concrete. So the vibrating needle should not be allowed to run over the placed concrete. So this is related to placing of the concrete. Again, you can see what we have to know about the placing of concrete. So the before placing of concrete, the formwork and reinforcement should be checked to make sure they are clean and free of any detritus or such as end of the tying wire. So before placing the concrete, so we have to check the formwork, we have to check the reinforcement, which should be make sure they are clean and free from the any disturbance. Then the fresh concrete should deposited as close possible to final position. We have to deposit the fresh concrete into the at their final position, and at that time we have to care should be taken when discharging concrete from skip to avoiding the disloading the reinforcement or over finishing the formwork. So over finishing the formwork and disloading the reinforcement, that we have to take care. When filling of column and walls, care should be taken that the concrete does not strikes the face of the formwork, which might affect the surface finish of the hardened concrete. So the whatever filling columns and walls are there, that should the care should be taken, and that care should be taken such a way the concrete does not strike the face of the formwork. So the formworkच्या फेसला ते concrete strike नाही झालं पाहिजे होताना, एवढी काळजी आपण घेतो का? नाही घेत. So the placing of concrete is a very important stage. So depends upon that your concrete strength will be concrete strength will matter. Are you getting? And next point related to placing of concrete is for the deep section, the concrete should be placed in uniform layer. So as I told, so we are filling the concrete or depositing the concrete into the column for the 7 feet height. एका 7 फूट हाईटला आपण कॉलम भरत असतो जनरली. So for this 7 feet height, we are placing the concrete from the height. Okay, so that concrete we have to place in the uniform layer. So that typical not more than about 500 mm thick. So 500 mm thick पेक्षा जास्त आपल्याला लेयरनी कॉन्क्रीट भरायचं नाहीये. And that 500 thick layer we have to compacted first, and then we have to go for the next 500 mm thick. So in this way we have to place the concrete into the RCC compound. Again, if you see, if we have to place the concrete into the foundation bed, then the foundation bed, to construct the foundation bed, we have to excavate the earth trenches. Then after excavation trenches, we have to, what is the procedure? That is the procedure for placing of the concrete. So the excavation of trenches, we check the bed of the earth trench. Then bed of the trench should be free from the root and organic matters and loose earth we have to remove. Then trench is wetted by the spraying the water to avoid the loss of the water from the concrete, and the tubes are used for placing concrete in drip trenches. So this is the this is the work we have to place the concrete in the foundation bed. Then if we have to place the concrete in column and deep beam, so then what we have to do? So while placing of concrete into the column or deep beam, it is not suggested to allow the free fall of the concrete more than a meter unless the mix design is to be designed to be dropped. So not more than 1 meter height, we can drop the concrete in the beam or column also. So that precaution we have to take, or we have to suggest that the not more than 1 meter we cannot fall the concrete or deposit the concrete into the column and beam also. Then falls of the concrete results in the segregation. If we fall the concrete freely from more than 1 meter height, what will happen? The segregation will be happen. So that we have to avoid. Then again, we use the trimmy pipe to drop cement concrete to cover the blocks, and we also use the sloping board. So this trimmy pipe is also we have to drop into the cement concrete to cover the, and also use for the sloping boards. So if you see some sketches, so then you will realize how we are doing the concrete in regular days. So if you see here, the first sketch, that is the two persons are standing, and the 7 feet column they are filling from the height of generally 2.5 meter. So this is the very bad way for the placing of concrete. If you see the second sketch, is this is the hopper. So like way you have to place the concrete. Then third sketch, this is the placed by the pump. This in the third sketch, the pump concrete is placed by the pump. And here fourth, this is the by spray. We are placing the concrete by spray. So in this way, we generally are placing the concrete. Okay. So the next point is the compaction of concrete. So after the placing, the compaction is also very important factor, because if we not compact concrete properly, then the void segregation voids will be present, then the porosity will be increases, and the the concrete may be observe the honeycombing, so that we have to avoid, and avoid that activities. We have to compact the concrete. So how to compact the concrete? So the next point is the compaction of concrete. So the generally compaction of the concrete is a process of the explaining and entrapped air inside the concrete mass. So whatever air is present into the concrete inside, that we have to expel from the concrete. That air we have to expel from the concrete. This process is nothing but the compaction. Then during mixing and transportation and placing of the concrete, the air gets trapped into the concrete mass. So during the mixing, during the transportation, and the placing of the concrete, so air get trapped into the concrete mass. So this air is not removed while placing the concrete. So the concrete will not get a complete strength. If the air content is present into the concrete, so the strength will be decreased. So that strength we have to remove by the vibrating the that vibrating or compaction of that concrete, so that we will get the strength. Then 5% of air voids reduce the strength by 30%, and 10% of the air voids reduce the strength by 50%. So the 5% of air voids reduce the strength by 30%, and 10% of air voids reduce the strength of 50%. So are you imagine, or are you thinking, if the 5% voids are present, the 30% strength will be decreases, and 10% voids are there, the 50% strength will decreases. So the compaction process is a very important for the achieving the strength of the concrete. So also the compaction is required to the durability of concrete is also reduced. If the air voids are there, then the durability is also reduced. What air voids air voids are present into the concrete? So how durability will be decreases? Because due to air voids, the internal air will be attacking to the steel also, concrete also, and there may be a chance of weak region and also corrosion of. So the density of concrete will be get reduces, so the durability is also reduces. Then some insufficient compaction increases the permeability of concrete also. So if the insufficient compaction if we do, then the permeability of concrete is also increases. Then the resulting that the aggressive chemicals in solution and the chemical attack of concrete and reinforcement and life of concrete is also reduced. So the air content we have to remove by the compaction. So that is very important. And so if we concentrate on that compaction, so all the other parameters or properties of concrete, the permeability, then the strength, durability will be increases if we do or use the proper compaction process. Okay, so what are the methods of the compaction generally we are using? So there are 3-4 methods we are using for the compaction of the concrete. So the first method is the hand compaction. So compaction by the vibration. Secondly, thirdly, the compaction by pressure and jolting, and fourth is the compaction by spinning. So these 4 methods we are following. So how we are compaction by the hand, how we are compaction by the vibration, then by the pressure and jolting, and by spinning, that we will see in detail also. So now the hand compaction. So generally, if you see the here picture, so in this particular picture, if you see the one of the here column or circular component is there, and the concrete is placed into that concrete. And here the person is having the steel rod into his hand, and he is what he is doing by compaction of that rod. So the hand rodding, hand compaction is a hand rodding. So poking inside the concrete with 1 to 2 meter long steel rod. काय केले, स्टीलच्या रॉडने 1 ते 2 मीटरच्या स्टीलच्या रॉडने आपण काय करतोय, ते खाचतोय. सो दिस इज दी हँड रोडिंग or hand rodding. So then second, ramming. In the hand compaction, second stage, second way is for the hand compaction is the ramming. So ramming is nothing but, if you see here, so like this, the rammer is there. So by using this rammer, this is the actually the method we use compact the plain concrete also. For we are using this PCC on the ground level and around the foundation. It is not used for the RCC, for the upper floor. So this ramming compaction method we are using in the where for the PCC only at ground level. So if you see the pictures, then we will see this is the ramming compaction method. So then third hand compaction is the tamping. So wooden beam is there used to beat the concrete. So low thickness slab or road slab, we use this ramming method. So as we are the familiar with the concrete, because we are the civil engineer, so generally we have seen this process. The mason गवंडी काय करतो, अशा पद्धतीची त्याच्याकडे एक वेगळ्या प्रकारची थापी असते, त्याला आपण टॅम्पिंग असं म्हणतो. By using this thapi, the mason will be level the surface and compacting slowly on the surface of the concrete. So this is the tamping method. The next is the, so we have seen 3 methods of under the hand compaction. So first is the hand rodding, then second is the ramming, and third is the tamping. So by using these 3 methods, we can compact the concrete by the hand compaction method. So then second compaction method is the vibration, compaction by the vibration. So compaction by vibration is nothing but, in the hand compaction, the water cement is water cement ratio is more, so we get less strength in the concrete. In the hand compaction, if the water cement ratio is more, so we will get the less strength in the concrete. And if we use the mechanical vibrator, so water cement ratio can be kept low, so we will get good strength. See, if we do the compaction by hand and if we do the compaction by mechanical vibrator, so there is a difference. So difference, what is the difference? If we do the compaction by hand, so the water cement ratio is, if the more, then we will get the less strength. But if we use the mechanical vibrator for the compaction, the water cement ratio can kept low, and so we will get the good strength of the concrete. So first method under the vibration is the internal vibrator. So this is, if you see the picture, this is the vibrator. So how we can use this vibrator, we will see in the next slide. So the internal vibrator, whatever image or picture we have seen in the last slide. So the most common use called the needle vibrator, or immersion vibrator, or poker vibrator. So we are calling this vibrator as a needle vibrator, or immersion vibrator, or poker vibrator. So why we are calling? Because we are the needle is present at the start. That needle we are inserting into the concrete and vibrating. Immersing, that immersion vibrator, why? because that needle we are immersing into the concrete, so that we are calling as a immersion vibrator. And next also we are calling that the poker vibrator. So these three names we have given to this internal vibrator. So that is the needle vibrator, immersion vibrator, and poker vibrator. So generally this internal vibrator consists of electrical and diesel powered supply, and the needle and shaft is there. So the needle and shaft is there, and that vibrator is consist of the electrical and diesel power supply. So electrically operated is there, or diesel operated supply is there. So we can use, depends on the our requirement. Then the frequency of the vibration can be 12,000 cycle vibration per minute. So the frequency of the vibrations we are using for the compaction purpose is a 12,000 cycle vibration per minute. So this is the frequency, and the needle diameter is the range from the 20 to 75 mm. Whatever vibrator we are using, so that vibrator needles are from the 25 to 75 mm. So generally less diameter we are using the thin wall. There may be a slab is there, there may be a other thin RCC paddi is there. So less diameter we are using, and more mass concrete is there. We are constructing dam, we are constructing heavy beams, we are constructing the girders. For that purpose, the greater size needle we are using for the compaction purpose. And the length of generally needle is 25 to 90 centimeter. The generally 25 centimeter, from the 25 centimeter to 90 centimeter. It means up to the 1 meter length of the needle is there. So the backside pipe is more long, but the needle is having a 25 to 90 centimeter length, and this will be the portable. So these are the some parameters, or some of the components of that needle vibrators we have seen here. So if you see this picture, so the here slab concreting is going on, and for that slab they have used the electrical supply needle vibrator. So there may be a diameter, if you we cannot seen here. There may be, I think, 25 to 30 mm size diameter is there, needle is there. And if we insert the if we place the concrete on the surface, and we have to immerse this needle into the concrete. So second type of the vibrator is the formwork vibrator. Second type of vibrator is the formwork vibrator. So the first vibrator we have seen that internal vibrator, which is we are inserting into the concrete. Why we are calling internal vibrator? Because we are inserting into the concrete. But the formwork vibrator is there. That second type of the vibrator is the formwork vibrator. That vibrator we are using for the column, walls, and precast slabs. And we are placing that vibrator on the formwork. So if you see, I will show the sketch. See, so these are the columns. Are you seeing? So if you see these columns, so the for the concreting, the steel bar. So these are the steel bars from the columns, and this is the formwork. So yellow color indicate the formwork, and for this formwork here, this is the vibrator is attached. So why we are calling formwork vibrator? Because we are vibrating the formwork. We are vibrating the formwork, so the concrete will compact. So the compaction process of the formwork. So here written the formwork vibrator for the compaction of the concrete. So that vibrator is kept or attached to the formwork externally, and if we apply the vibratory load on that through that vibrator, so the compaction process of the concrete will be takes place, and we will our target will be achieved. The target is the compaction of concrete. So this, in this way, the formwork vibrator we can use. So how looks the formwork vibrator, or what are some specifications of the formwork vibrators are? Actually this, as I told, this vibrator is we are using for the column, wall, and precast slabs. So the vibrator is clamped to the formwork, as I told. So the column is there or precast slab is there. So the externally for the formwork, this vibrator is attached or clamped, and vibratory load we are giving. Then vibration is given to the formwork. So if we attach this or clamp this vibrator into the for the formwork, so vibrations we are giving to the formwork. So the whatever vibrations transferred from the formwork to the concrete, then it will useful in the thin wall where the reinforcement obstruct the needle type vibration. So as I told, sometimes thin walls are there, पडदी म्हणतो आपण की ज्या ठिकाणी व्हायब्रेटर जाऊ शकत नाही. So in that case, what we are doing? So formwork vibrator we are using, so that the compaction process will be, we can maintain the compaction process, and so our target will be the air, whatever air present into the concrete, that will be the removed by the compaction. So we can use this compaction process by using this formwork vibrator, and the efficiency of that particular formwork vibrator is lower than the needle vibrator, because we are vibrating to the formwork externally. So there may be a less chance of the removing the air voids into the concrete. So as we compare with the needle vibrator, so the needle vibrator is good as compared to the formwork vibrator. So these two types of the needle vibrators we have seen, the needle vibrator and the formwork vibrator. So other next type we will see in the next lecture, that is the table vibrator, or other two vibrators are remaining. Okay, and other types of the compactions. So here today we will stop. Remaining part we will see in the next lecture. So wait, I will take attendance and then we will close.